Okay, recording. Hi, everyone, and welcome to this week's Q&A for Springboard. My name is Ryan Rosario, if you haven't met me, and I am a data science mentor for the intensive and career track. How this session works is a little bit different than our other sessions. You'll go ahead and just ask any questions you may have on your mind. You can use the text box on the side. You can also get on your mic. Since we don't have a huge audience, we don't have to worry about people talking over each other. So feel free to get on your mic and ask any questions you may have. It could be related to anything. I'm familiar with both R and Python for the Foundations and Intensive course. So if you have questions about evaluating models, fitting models, resources that you may need, questions about modeling, feel free to ask. So I see. I think for some reason the video is not switching to me.
I see you.
Oh, okay, perfect. Yeah. Uh, which language do you personally prefer, R or Python? This is a good question. It's a very controversial question in that it causes a lot of fights. It's like the VI versus Emacs question for text editors. For me personally, I'm sort of a data science engineer, so I focus on building systems, so building machine learning systems and whatnot. So for building systems, I tend to stick with Python, and the reason why I do that is because it lets me do all the fancy OS stuff that I would need to do to parallelize or to distribute, across cores or across systems. So that's usually what I use to build systems. I can also then use C++ or Python to make my code run a lot faster to use in a system. When it comes though to actually analyzing data or creating one-off graphics or reports, I'll then take the information that comes out of Python, whether it's for a system or an analysis, and put it into R. And what I like about R better than Python is that it's very quick to, it's very straightforward to create graphics in R. Matplotlib is a very, very good project for creating graphics, but it's very difficult to learn. It has a lot of nuanced syntaxes that you have, a lot of nuanced syntax, I should say, that you have to use in order to set up a really nice graph. Seaborn, which is covered in the intensive course, is sort of a wrapper around Matplotlib. It's similar to R's graphic platform and always being improved and whatnot. So that's made it a little bit easier to create graphics. But because of that, I have to use both of them. So whenever I'm doing analysis or trying to fit different models to data, I'll typically use R. But then when I go to build a system or use something in production, I'll do most of it in Python using pandas, SciPy, NumPy, and all that good stuff. When I was at Facebook, though, I did have to create a dashboard, and it was a manual dashboard. It didn't plug into Tableau or anything fancy like that. And so in that case, I had to use Matplotlib. So every time my machine learning classifier would run, or train, I should say, it would create a bunch of diagnostic plots on an hourly basis. And it would essentially create a Matplotlib plot that showed the diagnostics and then wrote it to disk, and I could access it through an HTML page so that people can see it. Then eventually we would port it over to the company dashboarding platform, which in some departments is Tableau, and in other departments it was a proprietary built-in system. So what you'll generally find is that people that are doing more analysis prefer R over Python. People that are doing more engineering, coding work, and system building will prefer Python. And it's a really contentious question because in the community, it's totally worth asking. I'm not discouraging asking the question, but it's contentious because a lot of times people don't word their answer carefully, and the R people get very offended, saying, no, R can do that. You just don't know how to do it. And then other people, in the Python side will get offended if you suggest R because they'll say, well, Python's better for system building. So it depends on the person, but generally I think that's basically the breakdown of how people use both. So Raul, welcome. If you have questions about anything, kind of how this session works for people that haven't been here before, or how it's meant to work, is if you come in, you have a question about anything. Could be a general question. It could be, what type of data should I use for my project? I'm thinking about using this kind of data, but I don't know where to get it or how to get it. Anything that might be in your mind. Treat this general Q&A like a college office hour. So just ask whatever's on your mind. We also have career Q&As, which are a little bit different. That's specifically about career questions, and they usually follow the flow of whatever we're talking about together, me and the person that I'm interviewing. And then we also have project presentations, which the Q&A for that is obviously about the projects that are being presented. So if you want to ask a question, you can get on your mic, you can raise your hand, or you can send me a message through the chat, and I'm happy to answer. I also tend to, for those of you that are here the whole session, I try to go through and talk about things that I'm working on, just to keep it lively while I'm waiting for questions, and some other things that are happening in the community. One thing that I recently read about, so to back up a little bit, I just finished my PhD dissertation and submitted it to my committee for review. So I'll be defending in March, and if all goes well, I'll finally be done with my PhD. So I haven't had a whole lot of time to research trends and play with data and stuff that I usually like to do. Thank you, Lana. She said congratulations privately, just so everyone knows why I'm thanking her. So once I'm done with that, I plan to get back into blogging and attending meetups and researching some things. But in the meantime, I came across something on Twitter. We mainly focus on R and Python in this course and in industry in general. There's other languages you can learn. One popular one that's gaining a little bit more traction is called Scala, and it's what Spark uses, or what Spark was developed with, I should say. And it runs on the Java virtual machine, which basically means you write your code in Scala, and it's converted into bytecode, which is interpreted by the Java virtual machine. So essentially, I think the theory behind it is that if you write Java code, if you write Scala code or anything that relies on the JVM, you can run it through Java or interact with it through Java, something of that nature. I'm drawing a blank now, but there's a really big advantage to doing that. And so there's a bunch of languages that you can learn, but to get back to the point of what I meant to talk about is I was reading a paper about what are called probabilistic languages. There's a package in Python called PyMC, and next week I'm actually going to see the developer talk. His name is Chris Fonsbeck. He's on Twitter. And he'll be giving a talk about PyMC3. But it's a probabilistic language or package. And what these languages do is they let you model things as distributions. So in Python, if you want to create a normal distribution, you have to or let's start with R. R is much simpler. You say R norm, and you give it a mean and a standard deviation and how many replicates you want to draw from the normal distribution. And you get a bunch of variates from the normal distribution. In Python, you can do the same thing through SciPy. You can call a random number generator and generate a bunch of normal random values from the normal distribution. But there's a different way to do this. You can generate a distribution or generate a variable without assigning values to it. It's kind of a hard thing to explain, but basically what I can say in this language is x equals normal. I now have x is now a normal distribution. It's not a value of a normal distribution. It is a normal distribution. And a lot of these Bayesian models, it's particularly used for Bayesian models, has this kind of flavor. So you have that the x or the data follows, let's say, a Bernoulli distribution, and that Bernoulli distribution has a particular model parameter called theta. And in the Bayesian framework, we want to apply what's called a prior to that theta, and we say that theta maybe comes from a beta distribution. So the beta distribution is another probability distribution that you can read about or Google about, and it's basically the Bayesian way of thinking. It's called the beta Bernoulli model. That's not important what the model is called. But the way that you specify the model is by drawing a picture, a graph of the variables and how the parameters, I should say, of the model and how they affect each other. So you have, two parameters and an arrow going between them. And basically what it says is this theta is basically the parameter of the Bernoulli distribution or something. And the way that you'd have to do this in Python is you'd have to define all these variables. And you'd have to define them with values that come from those distributions. But with probabilistic programming, all you define is a distribution that it comes from. So you say X follows a Bernoulli distribution with some parameter theta. That's it. You've declared it's a Bernoulli distribution with parameter theta. Then you define theta as, or whatever the parameter is, as coming from a beta prior. So I say theta equals beta, whatever the parameters of the beta distribution are. And I have two distributions I can now sample from. So hopefully I'm not, talking over everyone's head because this is a very, very statistical thing, this whole Bayesian framework. But if you've had to work with random samples in Python or R, basically this probabilistic programming paradigm makes it easier because you don't have to work with values. Instead, you just work with the distributions. So if you're interested in Bayesian stuff, I recommend looking into the PyMC package. I'll type that into for everybody. PyMC. And there's another language that's was built. The paper that I read was for a language called Edward. And it can be used with PyMC or something like that. But this is a paper that I came across on Twitter, which kind of gets me to another point. People always ask, how do I get involved? Once I finish this course, what are some other things I could do? Aside from getting a job, of course, getting a job is a great thing. Not only do you get money and everything, but you also learn more and improve your career. But until then, there's other things you can do. So one thing that I have done is blog. I stopped blogging when I joined Facebook because I didn't have time. And I was also very worried about confidentiality and all that kind of stuff. So when I left Facebook, I fell out of that. That habit of blogging, and now I'm trying to get back into it. I'm having a lot of fun doing so. One thing that comes up from our students, though, is I feel like I don't know enough. Nobody knows who I am. I'm worried that I'll sound like an idiot if I get something wrong on my blog. And those are concerns that I also have sometimes. They're not something that you should worry about, though. This is something called imposter syndrome. Now, when you're learning, of course, you don't know everything. I don't know everything, and I work in the field, and I'll never know everything. None of us ever will. But the idea is just to go out there and share what you know, share what you're learning. Even though nobody may comment or nobody may tweet your blog posts, you'd be surprised at who sees your blog posts. I've written long blog posts. I wrote one recently about what my resolutions in data science are for the year, and nobody commented on it. I like getting comments, but it happens. You write blog posts, nobody comments on it. But lo and behold, I'll go to a meetup and somebody says, "Hey, I really liked your article that you wrote." And I'm thinking, "What article?" Nobody commented on that one. They're like, "Oh, your resolutions article." And I'm like, "Oh, wow." So people are reading this stuff. So even though you think people aren't reading your work, they are. So just keep at it, and you'll gain a following whether you know it or not. I'll shut up for a few seconds because Lana has a question. Her question is, which sources would you recommend for procuring data? Kaggle, data is plural, etc. Okay, so this is a good question. I'm a mentor for the intensive class, which has a little bit different guidelines from the foundations course. So I want to make sure I'm correct in my answer. I believe for the foundations course, any of these resources would be good. The idea in the foundations course is learning R, learning some skills about how to analyze data using R that you can then take with you to be a data analyst or to continue your learning about data science. In the intensive course, we're a little bit pickier. We want you to have large data sets, basically things that can't really be considered toy data sets. And we also ask you to have data sets that aren't cleaned, meaning stuff that's really cleaned up. You don't have to do very much to clean it. Anytime you scrape data from the web, or you have to work with text, or you have to merge multiple data sets, you essentially have a situation where your data isn't clean. And that's what we want in the intensive course. In the foundations course, I don't believe that guideline exists. Maybe maybe it's a recommendation, but I don't know if it's enforced. So for the foundations course, Kaggle and data is plural. I would imagine both are perfectly fine. For the intensive course, we're a little bit pickier. Plenty of projects are done with Kaggle data in the intensive course. The problem with Kaggle data, though, is that it's usually very clean. And the idea behind Kaggle is trying to get the best machine learning model possible to get the best predictions. So because of that, the data is pretty clean because they don't care about that part. But as a data scientist, you're going to spend 90% of your day trying to clean up data. So we want to make sure we give you a lot of experience in doing that through this class. So as a mentor, I'm very picky. If somebody wants to use Kaggle, I'll often tell them to send me the data or give me a link to the data, and I'll look through it and make sure that there's enough of a challenge there for the mentee. Usually size isn't a problem with the Kaggle data set. The other issue is the issue of motivation. In order to complete your capstone project, you need to be motivated to complete it. And the best way to be motivated to complete a project is to be interested in what you're working on. So, Kaggle has a lot of data sets. Many of them may not be very interesting to you, though. Do not pick one of those. Pick something that looks very interesting to you or something that you have experience with through your work. So if you work in finance and you like finance, it may serve you well to find a Kaggle data set that's from finance. But don't pick a data set that you're not interested in. If you can't find any interesting data sets on Kaggle, look somewhere else. That's my best advice. There's a lot of people that get tripped up with Kaggle data sets, and they either don't produce good projects or it takes a long time to complete because they don't really want to do the work because the data set is so boring. Data is plural is an interesting one. This one is used a lot less frequently, I think, because it's a bit of a weird thing because it's a mailing list. It's not like a blog where you can see articles written with stuff. You have to subscribe to the mailing list, so it's a little bit less popular. But the data sets that are there are really good. They're really interesting data sets. I found a data set on delays at customs and border protection. So when you fly into the U.S. from another country, you have to go through immigration and customs, and there's usually a wait time with that. Well, I had no idea that somebody was actually recording how long it takes to get through these various things. It's available for all the major airports, huge data set. Had no idea it existed, found it through Data is Plural. There's a lot of these type of data sets. There's one on fake news. Someone's created a data set about fake news to create a classifier. Without Data is Plural, I would have no idea that it was there. The same problems though exist for Data is Plural though as it does for Kaggle. You want to make sure your data set's not too clean if you're in the intensive course, and you want to make sure that it's interesting. Data is Plural, I think, has a lot more interesting data sets than does Kaggle. They're very out there, so I recommend them. What do you recommend as an alternative data source? For example, web scraping. Web scraping is excellent. Is an excellent data source. There's other data sources as well, depending on what your interest is. I know somebody who's very interested in baseball. I'm not interested in sports at all, so I couldn't help a whole lot there. But apparently MLB has an API, meaning you can point your code to this API, request data from it, and the MLB, the Major League Baseball people, will send you back data about various things, whatever you ask for. So that's pretty cool. So whatever you're interested in, try to Google the website for that and then the word API afterwards to see if they have an API. If they don't have an API, then you'll have to screen scrape, which is a really good opportunity to learn Python better and a really good opportunity to learn a little bit of systems programming and fault-tolerant programming, because weird things happen with the web scraping. You can get banned if they detect that you're hammering the site. The site can go down, and then you have to deal with that, or there's a database issue. There's a lot of things, and you have to program defensively for that. So web scraping is an excellent resource to get data. They usually yield some of the best projects I've seen because it's data that you can't get anywhere else. You have to scrape it to get it. Once you know how to web scrape, the World Wide Web is open to you as a data source. There's still limitations. You can't scroll all of Facebook, of course, or all of Amazon or Yelp, but you can crawl some smaller sites that have data that may be even more interesting. A few calls ago, I talked about cocktails and a data set that I'm working on, and I had to crawl a cocktail recipe site that I think had 60,000 recipes or something. I tried looking for data sets and they just didn't exist. So I had to scrape the data, and it's always fun to do that. So I always recommend scraping data if you have the motivation to learn it. Some people are new to Python. And I should also back up and say you can also do this in R. So if you're in Foundations, you can also scrape through R. There's a package called rvest, written by the King Hadley Wickham, and that will let you partially scrape whatever you want to scrape it directly into R. I personally use Python for that, but R can also do it. So I'll quiet up for just a little bit in case anybody wants to get on mic or type in a question. Let me check to make sure see if anyone sent me any. Make sure that I'm not ignoring anyone. So another thing that's kind of interesting, I've been in a PhD program forever now, or feels like forever, but I guess it has been forever. And one thing that I've seen a lot of students come and go, mostly undergraduates, because they stay in college for 4 years and then they graduate and move on to other things. And what I've noticed is a huge uptick in the number of technical students. So they always say each generation is more technical than the last, and I believe it. But when I was a statistics major in college, we mainly learned SAS, SPSS, data. We learned a little bit of R, and we built models, and we did all this kind of model diagnostics, the stuff you usually use in statistics. But we didn't learn a lot about Python or programming languages or high-performance computing or Hadoop or Spark or any of that stuff. And what I've seen is that a lot of the people that are graduating college now are starting to teach themselves that stuff. So, going through this course is very helpful to help if you were a stats major. I don't think anybody is in this class, or very few people are in this class at least. It's good to refresh, because I don't want to say you compete with these people, but this is what people in college, which is supposed to prepare you for a career, are doing. So if you can emulate what they're doing, it'll help you with your career and help you get a job in the field. You're welcome, Lana. If you have any other questions, of course, feel free to type. Same with everybody else. We still have about 5 minutes remaining. So whichever class you're in, if you're in Foundations or Intensive or Career and Intensive I consider kind of combined in my mind, because the coursework is pretty similar, except the Career one is more career oriented, obviously. With Python, you can access a lot of the stuff that the new high performance computing things, such as Spark. Hadoop was a little bit of an issue for a while, because Hadoop is, I guess, because it's in Java. It's very clunky to connect Python to Java. Doesn't work really well, or it's not very seamless. So because of that, you had to use Hadoop streaming if you wanted to use Python or R with Hadoop. But with Spark, things are a little bit more native. Python is more of a first-class citizen. So if you want to learn Spark, if you want to learn TensorFlow, all of these things can be accessed through Python, and I believe they can be accessed through R as well. So by learning these languages, you're opening all these opportunities to you. TensorFlow, if you're not familiar with all the buzz that's going on in the field yet, is a system for deep learning, essentially. If you're into deep learning, I guess everybody's supposed to be right now. TensorFlow allows you to create a lot of these workflows, and it does some pretty cool stuff, and it's somewhat high performance. It's something that I want to learn when I get more time, but it can totally be accessed through Python. Same with some of these probabilistic languages that I was talking about. So I'm pretty happy and pretty excited that everything's coming to Python now. It seems like before you usually had to learn C++ or Java or some of these other languages that are used a lot in the software engineering field in order to do these things. So that's kind of exciting. Another thing that's I've been getting some questions about lately is this NoSQL concept. So back in like 2009, this is a huge deal. Everybody said, SQL's bad, relational's bad, use NoSQL. And if you're not familiar with this term, I don't want to say keep it that way, and I'm kidding. NoSQL can be interesting. Usually everything is in a table, and we talk a little bit about SQL in the intensive course. Databases are table-based usually, but there's other ways to represent data. You can have JSON files, which JSON is a popular format that you get if you call an API. It's basically a format that's native to JavaScript, believe it or not, and it's just basically a nested data structure that's used pretty frequently on the web. So there's things like MongoDB that you can use for querying with MapReduce JSON files, so you don't have to put all of your data into a table format. There's other things like in-memory databases. If you want to parallelize, you can read things from RAM. That's kind of interesting. There's a package called Redis, another one called Memcache DB. Both of those are really popular. There's another one called CouchDB, which is for XML. I feel like XML is going a little bit out of fashion because JSON is so easy to use. But it's another data store for XML. There's also graph databases. There's one called Neo4j. So if you have graph data like Facebook users or the Enron, if anybody's working with the Enron data set, where you have the various executives send an email to each other. You have the executives as nodes or vertices in the network and an email as an edge. You can represent that really easily as a graph in Neo4j. If you were to do that with SQL, you'd have to really design your tables well, and it's a lot of self-joins that you have to do there. So using network databases can be sort of interesting. And this all falls under that NoSQL header. But I've gotten a lot of questions about it lately, so I kind of wanted to talk a little bit about it since there's no other questions. We have a minute left, so if you have a question, ask now or forever hold your peace. You can type into the text box or get on your mic and ask. Either way is perfect. Okay, well, it's 5:30. We're going to work on this session a little bit in the sense on, what we do with it. We're probably, the way that this was sort of meant to run was that it would be a drop-in, just like in college. You have a professor, office hours, you have a question, you come and you ask your question and whatnot, and you can stay the whole time if you want. But that way people will get some questions answered or whatever, rather than people feeling compelled to have questions the whole 30 minutes and whatnot. So, we're experimenting. It's a startup. So we're going to continue working on this format. But next week we go back to either a career Q&A. I can't get the schedule memorized, but it's either a career Q&A or a project presentation. So we'll see you all next week. Have a great weekend, and thank you for coming. Have a good night.